Welcome back, everyone. Today we're going to take a quick tour through Lygia, which is a shader library that you can use within TouchDesigner to really easily create some complex shader scenes that would otherwise take a lot more work to reproduce. So here we're taking a look real quick at just one example scene, raymarching a bunch of different SDFs and texturing them with various colors. We're going to take a look at a bunch of different examples today. Before we get into that in TouchDesigner, I'm going to just hop into Chrome, and we can actually look at Lygia itself. So this is the homepage, lygia.xyz. As you can see, it is a shader library made of reusable functions, intended to allow you to prototype and build things very quickly. There are a bunch of integrations, as we can see here, including the logo that we know and love. We'll come to that in 1 second. Here on their homepage, they just have this little example that will be reloaded with a random shader every time you refresh the page. So we'll start by maybe porting over one of these examples as a way to get us started in just a second. It's a little bit more information about how to use Lygia in different applications, but not super necessary for TouchDesigner. There are a lot of these examples that are definitely very good to use based on different frameworks you might want to use them in. There are, of course, two for TouchDesigner that we can take a look at shortly. A little bit of information on how Lygia is organized. This is helpful because it lets us know kind of where we can look depending on what we're interested in. So we can see that there are kind of like different subfolders within the library that have functions based on tasks related to math, to animation, to generative functions like noises, distortions, filters, etc. There's a ton, and it will take some time to understand fully what all of the capabilities of the library are, but this is a good place to get started. Now, here is the other very important parts to check out before we get going, and that is, one, the license. So Lygia is licensed with a commercial license to anyone who is a supporter or a contributor. So you can either contribute to the code directly, or you can just support the code, which is not very expensive. I think it's something like $10 or $15, maybe monthly or something like that. I don't remember, but then you get a commercial version of the license, and so you can use it in all of your projects. And then finally, the credits and kind of who is behind this great library. Patricio Gonzalez Vivo is the creator of the library. He's well known in the shader community and has done a lot of great work. The Book of Shaders is something probably everyone who is at this point in their creative coding journeys has come across. That was also from Patricio. And as you can see, there are other very, very prominent minds and real legends in the computer graphics community, like Inigo Quiles and others referenced here, who have given their input into this library as well. So there's a lot of great power behind the library. There's a ton of great functionality, and we can be rather confident that most of the code is going to be optimized and running as well as it can. So definitely make sure that you get the right license for your projects. But without further ado, we can start talking about how to use this in TouchDesigner. So we can start. So we can start by just going to this integration examples and checking out the 2D examples for TouchDesigner and looking at both of these. So here, and this is the dynamic resolver. This dynamic resolver you can download and check out, but it requires an internet connection to run. And basically what it does is let you include functions from the Lygia library which is how you actually access this library in your code. So basically by just saying hashtag include whatever Lygia function you want, then you'll have access to that function. And as part of the design principles down here, there is one function per file, which is great because it means when you include a file, you get just a function that is named the same as the file, so you know exactly how to call the function once you import it. And that lets you then really atomically import the functionality that you need in your shaders. So here, this include Lygia /draw /circle.glsl is grabbing the circle function and then using it later in the shader. In this case, to draw a bunch of circles and then animate their position using easing functions. Now, we include things a little bit differently in TouchDesigner, and when we include, we actually need to include a dat, and dat names can't have this little dot in them. So, in the dynamic resolver, he actually allows you to write and include kind of exactly with the same syntax as you would in another environment that's using the .glsl. And then using the internet will dynamically fetch whatever proper functions are required based on those includes and create a big shader file that has all of your stuff in it. Now, I have used this and it is not my preferred way to work with Lygia and TouchDesigner, and that is because of the internet connection required. There ends up being quite a bit of lag. I mean, it's only half a second or so, but it's a lot when you're trying to quickly iterate on shaders. There's a lag that is required because the code that you write needs to get parsed and then sent to the web, and then the dependencies need to get resolved, and then all of that new text is now then brought back down and put into a text stat, which is then the shader. And all of this needs to happen anytime you change any character. So I found it very frustrating to develop, and therefore I prefer this version, which is a static offline version, which is baked into a tox, and you just drop the tox into your project, and then boom, you have access to all of that functionality for good, basically. So you could just download this tox. Just go ahead and download that, and then in TouchDesigner, you can literally just drag and drop it into TouchDesigner. I already have another one, so I don't need to do that, but it's as easy as that. And then how we can actually go about using the shader, I will show you by creating something from scratch, and then we'll go through the examples that I have already built. So this new shader, I'm just going to take from the Lygia homepage. I'm just going to grab this example, and we're just going to copy and paste this code, just like that. And we will just go in here and copy and paste all of our Lygia code. And now we just have to resolve a couple errors that will help us understand a little bit about how this is all working. And then from there, we can really dig in. So the first thing we need to do is just get rid of that if-def at the beginning. We need to go and add our uniform. So in this case, it can be uResolution and uTime are the two that we need. We will assign abstime.seconds to our time uniform, and our resolution will be for our resolution uniform. Now I will just drag and drop my project resolution onto my shader. Now, the changes that we need to make to our code are very minimal. We need to just replace these periods with underscores. Whoops. With underscores, and it will become clear in a moment why. And then the last thing we need to do is just create a out vec4 that we can call frag color. and then use that to actually send our pixel out instead of this GL frag color that they're using. I made a typo. This should be U_time. And now we have, just like that, a really nice ported over animation. Now, you can see how easy it is, but you may be wondering why we had to rename these includes with this underscore instead of the period. And that was what I mentioned just a moment ago. The way that includes work with TouchDesigner GLSL is that we actually include an entire dat. So, for example, if I had a text dat right here, and I had some function, maybe I wanted to define a float function called map, and then float x and float y, and then I will, in this function, just return what should that be? That should be x minus a over y minus x. And then if I called this map, and I wanted to include it in my function, or in my GLSL, and use that map function, I could include it like this. Include map. And then I would be able to use the map function here in my shader, saying just something very simple, like float m equals map, and then we can map, let's say, 0.5, 0, and 1, which obviously doesn't do anything because we're not using this value, but it shows you that we are successfully importing this map function using this syntax, because there are no errors when we are using it in our shader. So I'll get rid of this because we don't actually want that, but now you can understand how imports work, or include statements work in TouchDesigner GLSL. So we actually have DATs, and we're including entire DATs. So now we can jump inside Lygia itself, and we can see what's going on. And I have this all laid out. If you just grab the raw file and you jump into it, it's all going to be stacked, but you can just highlight them all, and then right click and go to layout, layout all, oops, and then you'll have all of your operators nicely laid out so that you can see them. And now we can see that inside of each of these there are more, so we can lay all of these out. And each of these is just a GLSL that has that function that's going to be included, and the naming conventions are function name underscore GLSL. So when we're including here, like let's say on line 5, with include Lygia draw circle underscore GLSL, that says, okay, go inside the Lygia component, go inside the draw component, find the circle function here, and then import this dat, or include all of the functions in this dat in whatever shader we're working in. And so that's what's happening, and that's why we need to change the dots to the underscores, because as we're all familiar with, TouchDesigner has a rule that says you can only have underscores as the special characters in your operator names. So us changing the periods to underscores just lets TouchDesigner know what dots to look at and resolves all of the dependencies. So just to reiterate, the things to do when you're trying to port one of those examples over is make sure that your uniforms are wired up, change those periods to underscores, and then make sure that you create an out vec4, I always call it frag color, and then use that frag color to output your final value to the top. Now we can take a quick tour through some other examples here and just start to get a feel for some of the other things that Lygia can help you with. So first, we just have a Julia fractal. And maybe if I split and then can edit the contents in the text port here so that it is easier to see. So we have this entire Julia fractal, and really all of the heavy lifting is coming from just a single function that is being included from the Lygia SDF. Similarly, this fisheye is really simple. It's just a couple lines of code, essentially just applying this fisheye filter to a background. Made very easy by just using this fisheye to XYZ GLSL function. You can also easily raymarch. In this case, we're raymarching a volume. So in this code, we again have our uniforms. One of the things that Lygia does is use define statements before the includes to set some parameters that are used upon inclusion. You can get more information about that by reading some of the documentation, especially this section, Flexible How, where it talks about using the define functions. And you can always also jump inside, like let's say, for example, we can go inside generative and we can lay out all of these. And then we can go inside of FBM. And so the define, let's say, additional parameters that you see being used over here in the raymarching example are implemented here. So basically, if there are defined values for these strings, then the defined values will be used. If not, these default values will be used. So by defining before we do the include, we can essentially cause this if and def, which means if not defined, this string to simply be skipped because the string will have already been defined, and therefore this definition will not be necessary. So you can always go and look at the individual functions themselves. There's documentation, or just by looking at what all of these different options are, you can then see what the different options for you to customize the functions by using these define statements are. So here, yes, we are setting some of those parameters. Then we are including a bunch of functions, defining the raymarch map, which in this case is just the frame of a box, and then just doing a simple raymarching in the main shader loop. This is our easing functions. This is the exact same thing as we ported over at the very beginning of this tutorial. So here we can see, so you start to get the feel, right? Each of these shaders has a very similar structure. There's uniforms, there are includes of all of the different functions that are necessary, and then there's some stuff, but really just the main loop that does all of the work. So the main loop will include, in this case, a bunch of different easing functions that the circle is just being animated between. Here are a couple PBR shaders. These are from Patrizio himself. Whenever you're porting these shaders from the internet, make sure that you understand the licensing attached to each of them. These are cool examples, but this is using largely some functions that Patrizio has built himself. And so we want to make sure that we're giving credit where due if and when we use these. Those I'll leave for you to explore. I would be lying if I said I understood all of the math in each of these. Now, this is the last example and the one that was up when we started. And I do want to talk about this because there's a little bit of a nuance when it comes to using SDFs in the TouchDesigner implementation of Lygia. I have made a note here, but essentially what you need to do is a intermediate step, which is just use the substitute dat to change the periods to underscores, and then rename using a null math underscore SDF and SDF, or sorry, math underscore GLSL and SDF underscore GLSL, so that you have properly formatted includes that something like this can use without error. So you don't need to do that if you are using the Lygia component that you grabbed from my Patreon, because I've already done all of this for you, and we'll bake it in with all of these examples. But then you should know at least why I made that change in case you try to pour something yourself and run into a little bit of a problem. So again, the reason is because in this shader, we're including just all of the SDFs using this include SDF GLSL, which is this component. And originally, I guess the original port just has a small error here, and it still keeps these periods. But there's going to be an error if we get rid of this substitute for now. We have an error, and that's because using our info, we can see that this include cannot process the directive for the header name circlesdf.glsl. And that is because circlesdf.glsl does not exist because all TouchDesigner DATs have, here we go, SDF, because all DATs in TouchDesigner obviously have names that are going to include underscores and not periods. So again, I'll lay out all of this just to show, and here is the function that we're looking for, but this has an underscore and not a period. Right, circlesdf.glsl, circlesdf underscore GLSL. So we just fix that really quickly in one place by using the substitute dat, which just substitutes period for an underscore, and we do that for both the SDF and the math GLSLs so that we don't run into this problem in the future. Now I just save this component in my palette, and I just drop this in whenever I'm going to create shaders that will use functions from the Lygia library. Yes. So I think that is probably a pretty good point to leave this tutorial. I don't want it to get too long. Hopefully it is now a bit clear how you can use Lygia as a library to create some of your own shaders from scratch and start to really dig a bit deeper into shaders within TouchDesigner using this library to make quality of life a lot higher.